Okay, welcome back. In the previous lecture, we ended with example 33. So now we are going to continue looking at examples for complex annuities. So the first example is example 34. And example 34 is very similar to example 29, except that now we are going to work with a complex annuity. So let's have a look at example 34. Mr. Pasi is planning to purchase a holiday home in Port Alfred. A loan of 400,000 rands is secured at an interest rate of 21% per annum compounded monthly. The loan is to be paid back with annual payments over the next 20 years. The first payment falling due 1 year after securing the loan. Find the value of the payments. So we say that this is a complex annuity because the payment period and the compounding periods are not the same. The compounding period is compounded monthly and the payments will be annual payments. So that is why we say that it's a complex annuity. Okay, so the first thing we have to do is we have to find the equivalent effective interest rate per payment period. Now the payment period is per annum and the compounding period is monthly. So we would like to find the equivalent effective annual interest rate. So we would like to find I1. Now we will make use of our formula to find the equivalent effective interest rate. Okay, and we have the effective monthly interest rate. We have IM or I12 in this case. The interest rate is 21% per annum compounded monthly. So the effective monthly interest rate will be the 21% divided by 12. So my M is equal to the 12 and my P is equal to the 1. And if I calculate this, I can write it as and this is then a percentage, and that is per annum effective. Okay, so that's the first step. Now we have the equivalent effective annual interest rate and we have annual payments, so we can continue as if we are working with a simple annuity. So we start out with the formula for the present value of an annuity. Okay, and because we are looking to find the payments, we can write it like we've done in previous examples. The payment is equal to the present value and we are dividing the present value with this whole factor here, or we can write it as this factor to the power minus 1. That's exactly the same thing. And then we just do the substitution. So our present value is the 400,000 rands. And now we substitute our equivalent effective annual interest rate, and we do that in terms of, or we write it in decimal form. So that is what we have calculated previously. And our K is now 20 because we have 20 annual payments. And this is everything to the minus 1. Okay, and then you can do your calculations. I don't have space for that, so I'll just write it here. Okay, so to settle the debt, Mr. Pasi will need to make 20 equal payments of this 94,038 rands. Okay, next let's look at example 35. Example 35 is very similar to example 30 that we did for simple annuities, except now we are going to work with a complex annuity. So let's read through this example again. Dr. van Rooyen is planning to set up a private practice. She requires a loan of 500,000 rands, which is secured from a local bank at an interest rate of 18% per annum compounded monthly. A budget allows equal half-yearly payments of 80,000 rands each, and the first payment falling due exactly 6 months after securing the loan. Determine the required number of payments. So if we start out with our timeline, this is time t0, and the loan size is 500,000 rands. The first payment is done after 6 months, and the payment is equal to 80,000 rands. Okay, so the first thing is, or let's just write down the information that we have. We have that the interest rate is 18% per annum compounded monthly. And then the payments are done semi-annually every 6 months. So that's why we say it's a complex annuity. The compounding period is per month. The payment period is every 6 months. So the first thing that we need to recognize here is, where do our annuities start? Now remember, we said that an annuity starts one payment period before the first payment. Now a payment period in this case is 6 months. It's semi-annual. So the annuity will start 6 months before the first payment. So the annuity will start at time t0. So my annuity starts at time t0. Now the next thing we need to do is to find the equivalent effective interest rate. And we would like to find the equivalent effective semi-annual interest rate. So we would like to find I2. And we have the effective monthly interest rate. My M is 12. My P is 2. My effective monthly interest rate is the 18% divided by 12. This is 9.34% per 6 months effective. And now we can again start with the basic formula for the present value of an annuity. And in this case, we would like to solve for K. We did previously, we went through the whole process of how do we rearrange my basic formula to solve for K. So I'm not going to go through those steps again. If you are not certain, I would suggest that you go back to example 30 in a previous lecture where we went through this whole process. So if you want to solve for K, okay, and now we just do the substitution. My present value is the 500,000 rands. My payment is 80,000 rands. And then my interest rate, we now use the interest rate the equivalent effective interest rate in decimal form. I don't have space for all the decimals here, but you can use all the decimals there. And if we solve then for K, we get 9.8187 half yearly payments. Okay, so to simplify this problem, we will round up K and report the approximate number of payments of 10. To conclude this, this lecture, I would like to redo this example and redo it on the financial calculator. So I suggest that you take out your financial calculators next, and then we will redo example 35 on the financial calculator. Okay, so to do example 35 on your financial calculator, you first start by clearing everything from previous calculations. So you take your second function, clear everything, and then you press again your second function button and payments per year. And you make your number of payments per year, you will type in a 2 and enter it. The reason for that is we have semi-annual payments, so we have 2 payments per year. Then after you've entered that, you go with your down arrow and you will get to your compounding number of compounding periods per year. So in this case, you will change it to 12. For the simple annuity, your payments per year and your compounding periods are the same, but for a complex annuity, we now change that to a 12. That's a 12, and you enter that as well. Okay, and then you clean the screen. And you can now type in all the other information for this annuity. So you will have your 18 for your interest rate per year, your present value will be 500,000 rands. And then for your payments, it will be 80,000 rands. But remember, if your present value is positive, then your payments must be negative. So to make that a negative, you will use the plus minus button. And that will then be your payment. So you will use your payment button for that. And now you can calculate the value of n. So you will say compute. And so that's compute and press in. And that should give you exactly the same answer, 9.8187 half yearly payments. Okay, so this then brings us to the end of chapter 2. You can do the class exercise in your own time, and there are many exercises at the back of chapter 2 which you can also attempt, and that will give you very good practice in annuities.